Hello, my name is Yasuyuki Nakamura from Nagoya University. The title of my today's talk is Analysis of Students' Answer Process based on stack answer data. And this work is collaborated with these members. In this study, we would like to propose a visualization method for the analysis of stack answer data, with a particular focus on the analysis on the answering process. After the introduction, the objectives are clarified and previous studies for the analysis of the solution process are presented. Then, the data treated in this study and the methods of analysis and visualization are explained, and we summarize this study. One of the most important features of learning management system is online assessment, specifically the computer-aided assessment. Computer-aided assessment can assess students' answers as correct or incorrect automatically and instantaneously. Traditional question types are true or false, multiple choice, fill in numeric, etc. In contrast, mathematics e-learning system can provide questions and calculation in which mathematical expressions with an algebraic style are automatically assessed. Stack, numbers, web work, Möbius, and so on are examples of math e-learning system. By using math e-learning system, partial score is possible when an expression only satisfies some of the required properties. Next, we describe the objectives of the study. We would like to analyze the process of answering question in other words, by using the function of categorizing incorrect answers. What kind of incorrect answers students went through before arriving at the correct answer. Kurihara, one of my students, represented the answer process of a student as a directed graph and visualized the overall tendency of the answer process, which we will see later. However, there is a drawback that detailed temporal information is unknown. We compensate for this by analyzing the tendency towards correct answers by visualizing the time variation of the types of incorrect answers. We also want to investigate how feedback influences the student's answer process. Let me show how Kurihara visualized the process of solving integral questions. Let's consider the question of integration of these rational functions. Correct answer is this, and students should enter their answers in this way. Students' answers are assessed by this potential response tree. For example, at node 1, the student's answer is differentiated to determine whether it agrees with the integrand. And if yes or true, the answer is correct, and the type of answer is 1. Otherwise, the decision is made at node 2, and so on. Kurihara examined the answer process of 94 students and represented the process of which incorrect answer led to a correct answer for each student in a directed graph. And he overlaid them all and represented them in a single graph. More transitions in answers are represented by thicker graph. For example, the graph shows that the answer categorized as incorrect answer 0 is answered many times, and answer 1 was often led from the incorrect answer 0. This suggests that the potential response tree needs to be improved in order to be able to categorize the incorrect answer 0 in more detail. There are pros and cons of Kurihara's visualization of answering process by using the directed graph. Pros are that It is possible to identify overall trends in the solution process, and it is possible to give tips on improving the potential response tree, which means there are many self-loops at node 0, then potential response tree should be improved to provide more detailed categorization of incorrect answers 0. Cons are that detailed temporary information of answering process of each student is unknown, and it is not clear how feedbacks influence the student's answering process. Therefore, the objective of this study is to compensate for the cons by analyzing the tendency towards correct answers by visualizing the time variation of the types of incorrect answers. Let me show the data to be analyzed. We deal with data from 94 students who took a liberal arts mathematics class in 2021. The data can be downloaded from the response of the stack database. Here is the raw data. The important item is the date and time the answers were completed, which allows us to organize the order of the answers for each student. From this information, we determine which of the submitted answers belonged to incorrect answers. Analysis method. We also use the question of integration of this rational function. We grouped students' solution into 6 categories. The numbers in brackets indicate the degree of error, which means that the larger the number in bracket is, the greater the degree of error becomes. For example, degree of error of correct answer is 0. And if arctangent x is mistakenly written as -1 power of tangent x, it is simply a typing error, and the error level is set to 1, a smaller error level. We visualize the solution process for each student. Specifically, we visualize how each student's incorrect answer leads to the correct answer. By the way, there may be other ways of categorization of incorrect answers, but the purpose of this study is to introduce the visualization method. So, the categorization policy could be a topic for another time. We represented the 94 students' answering process in a 3-dimensional line graph. The horizontal axis represents the order of attempt, and the vertical axis represents the error level. The students are arranged in the depth direction. Colored dots indicate the type of error, and colored line indicates which error type the answering process started with. This figure allows us to see the general progression from the incorrect answers with high error levels to the correct answers. In the right half of the graph, the solution process is divided into the graph of the number of attempts to reach the correct answer, in order to display the information in an easy-to-understand manner. From these figures, in the case of more than 5 attempts, we could see how students were trying, namely, getting closer to or farther away from the correct answer. Let us summarize this talk. We analyzed the solution process on the subject of integral questions involving 3 types of integrals. We proposed a method for visualizing how students go through incorrect answers to get to the correct answers. We used 3D plot with 3 axes: number of attempts, student number, and type of incorrect answer. We found that in the case of more than 5 attempts, we could see how students were trying, namely getting closer to or farther away from the correct answers. Therefore, appropriate feedback may help students to understand. As a future plan, we'd like to study the effect of how feedback intervenes in the improvement of students' understanding in mathematics online tests. Thank you for your attention.